Hey guys, and welcome to the full course on Introduction to Electronics in Automotive Systems, your gateway to understanding the evolution and cutting-edge innovations in automotive electronics. This is a certified course, so make sure to fill out the form in the description after completing the session to claim your certificate. Don't forget to proudly share your achievements on LinkedIn and showcase your new skills. At Skill-Lync, we are dedicated to providing advanced, industry-relevant engineering courses crafted by professionals with expertise in the field. Before we begin, make sure to subscribe to our channel for more insightful tutorials and updates on cutting-edge engineering tools, techniques, and courses. Hit the subscribe button below and stay tuned. Here's a brief overview of what we will cover in this training video. In the first module, we will dive into the evolution of electronics in automotive systems. From the early mechanical machines to the modern-day electronic marvels, you will see how the increasing use of electronics has transformed the automotive industry. In the second module, we will explore the various application areas of automotive electronics. This includes body electronics like lighting, security systems, and power seats, as well as driver information systems, powertrains, and in-vehicle communication systems. In the third module, we will analyze the typical messages processed by an ECU or the electronic control unit, such as engine torque, vehicle speed, and throttle position, while also introducing the key sensors used in modern cars like mass airflow sensors and manifold absolute pressure sensors. In the fourth module, we will break down the two types of safety systems, passive and active. You will learn about passive systems like airbags and how they save lives during accidents, as well as active systems like anti-lock braking systems, traction control systems, and electronic stability programs which prevent accidents altogether. In the fifth module, we will discuss the role of infotainment and navigation systems, from GPS and multimedia features to Bluetooth connectivity and onboard navigation. You will understand how these systems enhance the driving experience. In the sixth module, we will take a closer look at the instrument cluster, covering essential components like speedometers, tachometers, odometers, and trip meters, and their role in providing real-time feedback to the driver. In the seventh module, we will focus on the body control module, which includes HVAC systems, power windows, central locking, and immobilizers, showcasing their contribution to comfort and security in vehicles. In the eighth module, we will explore in-vehicle communication systems. You will learn how subsystems like multimedia interfaces, powertrains, and safety buses communicate seamlessly to create a unified driving experience. Finally, in the last module, we will discuss career paths and job opportunities in automotive electronics. You will gain insights into the required skill sets, including embedded systems, sensor integration, and programming, while also identifying target companies like Robert Bosch, Mahindra, and Continental. Thank you for joining us. We are thrilled to have you on this learning journey. Don't forget to subscribe to our channel for more updates and detailed tutorials. Complete the session, earn your certificate, and share your achievement with your network. Let's get started with Introduction to Electronics in Automotive Systems and unlock your potential in shaping the future of the automotive industry.
We shall see the role of electronics in automotive systems. So let me quickly walk you through the list of topics that will be covered in this webinar. Then we will try to understand the application areas where electronics can enhance the driving experience of a car. As we are going to learn about electronics in car, it is important for us to understand the type of messages that we have to process. For this, we will quickly take a look at typical messages from ECU. One of the important applications of electronics in car is safety systems. The next topic in our webinar will be safety systems. There are two types of safety systems, passive and active. We will see this in detail in the upcoming slides. Under passive safety system, we will check airbags and how it helps in saving life when accidents happen. Under active safety system, we will check anti-lock braking system, traction control system, and electronic stability program. Out of these topics, we will see anti-lock braking system in detail. After covering these topics, we will quickly check infotainment and navigation system, instrument clusters, body control module, and in-vehicle communication system. We will end this webinar by looking at the possible career path, job opportunities, and skill sets required to establish a career in this industry. I request all of you to kindly share your questions to the coordinator. The last 15 minutes of today's webinar is devoted exclusively for questions and answers. So friends, without any further ado, let's dive deep into our webinar with the first slide, Evolution of Electronics in Car. Before I get into this graph and explain what it means, I'm sure every participant is curious to know why should we even bother to learn about automotive electronics? Why automotive electronics is a topic of discussion today. So electronics in car, as you know, is increasing year by year. Gone are the days when automobiles were seen as mechanical machines. The drawbacks of mechanical systems, like limited accuracy caused by undetected failures, posed life threats to consumers. Soon, safety of consumers was seen as the need of the hour. As the popular saying goes, necessity is the mother of invention, and this led to electrification of cars. I hope it is clear why there is a need to learn about automotive electronics. So with that, let's move on to this graph. So as you can see, in the x-axis, you have the years starting from 1976 till 2020, and of course, it is also projected till 2030. In the y-axis, you can see the cost of electronics in terms of percentage of total cost of the car. Okay, and as you can see in this slide, the cost of electronics as a percentage of total cost of car worldwide from 1970 to 2030 is gradually but steadily increasing. By 2030, it is predicted that 50% of the total cost of automobile will be due to electronics in it. Okay, so now let's move to the next slide. Let us quickly take a look at the list of application areas where electronics can be applied. The first one is body electronics, which includes automotive lighting, car access and security systems, mirrors, body motors, power seats, and body sensors like obstacle detection sensor and vehicle occupant detection sensor. All this comes under body electronics. Before we proceed further, I want to share one more point. In the slides, you'll see only few points. I'll be explaining each point when I'm taking the session. You'll not find every word in the slide, okay? Just the hints in the slide. So we'll move on. The other application areas of electronics include driver information system, powertrain vehicle dynamics, vehicle network systems or in-vehicle communication system, sensors and actuators in car, infotainment system, navigation and connectivity system. Okay, so here the next slide is a fun fact. This is a very important fact. In 1968, Volkswagen introduced the first consumer vehicle available with a computer. It was a transistorized, electronically controlled fuel injection system. The first production of automotive microcomputer ECU was a single function controller used for electronic spark timing in the 1977 for General Motors Oldsmobile Tornado. For those of you who's thinking what is Oldsmobile Tornado, it is a personal luxury car manufactured and marketed by Oldsmobile division of General Motors from 1966 to 1992, over 4 generations. In 1978, General Motors offered as an option its Cadillac Trip computer on the Cadillac Seville. For those of you who don't know what is Cadillac Seville, it's also a car which was introduced in 1975 by General Motors. The computer, a modified Motorola 6802 microprocessor chip, displayed speed, fuel, trip, and engine information. So that's about this slide. So we'll move on to the next slide where we try to understand the typical messages that are given to ECU from various sensors in car. ECU stands for Electronic Control Unit. The typical messages that is processed by ECU includes engine torque, accelerator position, engine speed, throttle position, engine request, engine status, vehicle speed, and odometer, air conditioning, and finally OBD data. OBD data stands for onboard diagnostics data. Before moving on to the next slide, I want to share what are the different types of sensors, a brief overview about different types of sensors in car. So a modern day car includes following sensors: mass airflow sensor, engine speed sensor, oxygen sensor, spark knob sensor, coolant sensor, manifold absolute pressure sensor, fuel temperature sensor, voltage sensor, camshaft position sensor, throttle position sensor, and vehicle speed sensor. I'll just explain two or three of these sensors so that you get a feel of why we need sensors in car. So starting with mass airflow sensor, it is used to measure the air density to calculate the amount of fuel that is required to burn. Next is spark NOx sensor, which is used to ensure fuel is burned smoothly. Manifold absolute pressure sensor, which monitors the load of an engine. So that's about sensors. And as we are going to talk about automotive electronics, we can't skip embedded system. And for you to integrate all these sensors to a controller, your ECU electronic control unit is nothing but a microcontroller inside. So you have to know there are three types of output that you can expect from any sensor. One is analog output, the second is digital output, and the third possibility is PWM or pulse width modulation output. So let's briefly see what each of this mean. Analog signal means it is a continuously varying value, and digital signal or digital output is a signal that is being used to represent data as a sequence of discrete value. PWM is a series of square waves. In other words, I would say PWM is a way of digitally encoding analog signal values. Now let us look at the next topic, which is one of the most important topics we will cover today, that is safety systems. As already shared with you all, safety systems in a car consist of passive safety system and active safety system. Now let us look at these one by one. Before I dive into the topic, I want you to imagine as we are driving your car, and let's say for some reasons the car meets with an accident. So the point when your car meets with an accident and the point the passengers inside the car are saved, that period is crucial, and that action is taken by a system called passive safety system. Okay, so we have already seen that there are two types of system. One is passive and the other is active. So moving on to passive safety system. So as I said, the point where your car has met with an accident, from that point, passive safety system will take control and it will ensure the life of the passengers are saved. So let us see passive safety system in details now. Passive safety system comes into picture post-impact. That is, it plays a role only after the accident has taken place, which means these systems play after the accident has happened. For example, seat belt and airbag systems. The primary purpose of passive safety system is to save life in case of an accident. It is worth to mention these systems play no role in avoiding the accidents. Hence, these systems do not help avoid accidents. Now, this point will be clear when we look at the active safety system. Now, the next topic, before I move, I want you to imagine again that you're driving your car. So we have already seen there are many sensors in the car, and when you're driving the car, each of the sensor will monitor the driving conditions, and it will constantly give input to your electronic control unit. So this entire sensor and ECU will constantly look for circumstances or behavior pattern that will predict accident. And when such an accident is, such a behavior is predicted, active safety system will come into picture and it will completely avoid the possibility of accident itself in the first place. Okay, so let us see the active safety systems in detail. We are going to see what are active safety systems and how are they different from passive safety systems. Active safety systems comes into picture in pre-impact, that is, these systems play a role before accidents happen. Examples include anti-lock braking system, electronic stability control system, lane departure warning system. Okay, these are examples of active safety systems. The primary role of these systems is to prevent accidents. It is interesting to note in case of failure of one of these systems, it does not play any role in saving the life of a passenger. That is the role of passive safety system. Now this point is very important to understand how active safety system is different from passive safety system. So before we dive into the details and take up the example, I want to once again mention that when you're driving a car and we have sensors that is constantly monitoring the driving pattern, So when this pattern is monitored and the accident behavior is observed, active safety system will take control and try its best to avoid accidents. That's where anti-lock braking system, electronic stability system, and traction control system comes into picture. Now imagine active safety system fails and the car meets with an accident. After that point, passive safety system comes into picture and it ensures in spite of accident, the life of passengers are saved. So we're going to see these one by one. So starting with airbag control system. Before I get into airbags, okay, I want you to know that airbags can be dangerous, okay, and we'll get to this point at the end of the webinar. So airbag control systems, what are they? It is a passive restraint system which determines crashes and deploys airbags, thus preventing the loss of human life in crash situations. An electronic control unit processes a signal from an accelerator sensor, and based on an algorithm, it deploys airbags. The role of airbag is to prevent injuries to vital parts of human body. What are the vital parts of human body? Its head, chest, and face. Now there are some prerequisites to effectively use airbags in preventing injuries. That includes passenger is in seating position, passenger is wearing seat belt, not too many passengers in a car, and no child sits in front facing the rear. Now we have to understand why these prerequisites are there and how each of this plays a role. So starting with the first point, which is passenger in seating position. As you might know, airbags are positioned in fixed points in car. So you have this front airbag that is positioned inside your steering wheel, and there are certain airbags on the side, and you'll also have some luxury cars which provides carpet airbags. That is to protect your feet. And then there are some airbags for protecting knees. It's called knee airbags. So when an accident happens, it's very important that we follow corrective seating positions. Only when we follow corrective seating positions, the vital human parts will be targeted by the airbag and it will be able to effectively save the vital target parts of human body. That's why the correct seating position is important. The next point is wearing seat belt. There are two important factors why this is important. Let's look at the first one. First is, imagine you're not in the corrective seating position. Instead of purchasing a car with airbags, you will not enjoy the benefit of having airbag because it is not effectively protecting you from an accident. So this seat belt, when you are plugged into seat belt, you are 80 to 90% in correct seating position. So the seat belt helps you to automatically sit in correct seating position. So that is one advantage and why it is a prerequisite. Secondly, imagine you have a car with airbags installed, but you have parked your car and gone to have food in restaurant. And unfortunately, a rogue driver comes in and he has hit your car when the car is parked. Okay, so here I want to mention that airbags are one-time use. So when you have an airbag deployed in your car, you cannot reuse the same airbag. So when your car is parked and somebody hits your car and nobody is inside the car, there is no need to deploy airbag. Okay, and how is the algorithm checking this? It will see if the seat belts are plugged in, because a car that is parked will not have a seat belt plug in because there are no passengers that will need to use the seat belt, and that's why wearing the seat belt is important. Now the next point is not too many passengers in the car. Now this is again important, okay? When you have a lot of people sitting in a car and airbags will be deployed with a lot of force and pressure in a fraction of a second. So when you have many people sitting inside a car, you can collide with each other and that itself can lead to injuries. And that's the only simple reason why it is not encouraged to have too many people in car. The last point is no child sits in front facing rear. Now you must understand airbags are designed for adults. When you have child sitting in the front, the position of airbag will not be effective in saving the life of child. And another important point to notice is airbags will be deployed in a fraction of a second with a lot of force. So the force can hit the child and leave bruises, or it can even lead to suffocation. And due to these reasons, child can experience severe damage. And for these reasons, these prerequisites are important and it must be taken care. So we move on to the next slide. As the purpose of airbag is to prevent the passenger body from hitting the car, not one airbag is enough. Let us now look at different types of airbags in a car. As you can see in this slide, different types of airbag includes front airbag, curtain airbags, knee airbags, and inflatable carpets. Let us discuss airbags in some more detail. There are three parts to an airbag system that helps to accomplish passenger protection. These includes the airbag itself, crash sensor, and the inflator. The airbag is made of a thin nylon fabric which is folded into the steering wheel. The crash sensor is a device that tells the bag to inflate. And finally, a rapid pulse of nitrogen gas is used to inflate the airbag. So let us look at how does this airbag work. The working principle of airbag. When the crash sensor detects the accident, the airbag systems ignite a solid propellant which burns extremely rapidly to create a large volume of gas to inflate the bag. Nitrogen gas used to inflate the bag is obtained from chemical reaction of sodium oxide and potassium nitrate. So these two gases react with each other when an accident happens, and that leads to the outcome of an airbag. So with this slide, we complete the passive safety system. So before moving on to active safety system, I want to give some more fun facts. Okay, these are important facts to keep in mind. So the first one is in 1978, Bosch introduced the world's first anti-lock braking system. In 1986, Bosch introduced world's first traction control system. And in 1995, Bosch introduced the world's first electronic stability program. Now in this webinar, we are going to see each of this in detail with special focus on anti-lock braking system. Now before I dive into these topics, I want you again to imagine something. That is, you imagine that you're driving a car after heavy monsoon rain, and due to wet and slippery road, there are chances that your car can spin out of control. That is, there are chances you might lose control of your car and meet with an accident. To avoid this situation, anti-lock braking systems are introduced. Our next topic of discussion is anti-lock braking system, or ABS as it is famously known. Let us start examining the purpose of ABS. There are two main objectives of ABS systems: maintain steerability of the vehicle and maintaining the vehicle stability during braking. I would like to take you guys to your childhood to help you understand anti-lock braking system. Let's see how we can understand anti-lock braking system by our childhood experience. I am sure all the participants would have driven bicycle in their childhood. I hope you would have also noticed a pair of brake pad that grips the wheel whenever you press the brakes. Basically, you're using brake pad friction to stop your bicycle. Now imagine you are driving fast and suddenly you have to press the brake hard. What do you think will happen? You will notice that your wheels will stop moving, but due to the momentum your bicycle has gained, it will continue to move forward before it comes to a halt. And imagine you have a car or some other obstacle in front of you, you can hit the obstacle. Though you have pressed the brake, accident will happen. Now let us revisit this situation with slight difference. Okay, so let's assume you're driving your bicycle, you're driving it fast, and you have seen an obstacle in front of you. And instead of pressing your brake hard, what you do is you press your brake for some time, and then you release the brake, and then you press your brake again, and then you release again. So by doing this, you are reducing the speed of your cycle, and at the same time, you're ensuring you have control over the cycle. And in case you want to move, you can move. Such braking principle is called cadence braking principle. And this cadence braking principle is the foundation of anti-lock braking system. So let's look how this will work with a car. Imagine if you applied hard brake on a wet road, you might not be able to steer the vehicle as the wheels might get locked. The car might continue in a straight line, however much you turn the steering vehicle if your wheels are locked. In such a situation, the best driving technique to follow is to pump the brake while you also steer simultaneously. This technique is called cadence braking. These days, complex ABS system does this technique for you. how ABS works. In this slide, you can see how ABS uses cadence braking technique to always ensure steerability and vehicle control. If a wheel threatens to lock under heavy braking pressure, the ABS system cuts off the braking pressure on this wheel only. If the wheel no longer threatens to lock, the braking pressure is raised again. This leads to reduced stopping distance, steerability while braking, and maintaining stability while braking on inhomogeneous surface. Let us move on to the next slide and look at the main components of an ABS system. An ABS system consists of speed sensor, valve, pumps, and controller. Let us see the role of each of this in ABS system. So a speed sensor, it provides the ABS the information to decide the speed of the vehicle, whether the wheel is going to lock up or not. Valves, there is a valve in the brake line of each brake controlled by the ABS. In one position, the valve is open and pressure from the master cylinder is passed right through to the brake. In the second position, the valve blocks the line, isolating that brake from the master cylinder. This prevents the pressure from rising further, even if the driver pushes the brake pedal harder. In third position, the valve releases some of the pressure from the brake, and pump is there to provide the braking pressure. Now, before moving on to the next slide, we have to understand how ABS controller makes use of all these components to successfully implement ABS system. The ABS controller monitors the speed sensor at all the times, looking for extraordinary deceleration in the wheel. Right before a wheel locks up, it will experience a rapid deceleration. If left unchecked, the wheel would stop much more quickly than any car could. The ABS controller knows that such a rapid deceleration is impossible, so it reduces the pressure to that brake until it sees an acceleration. Then it increases the pressure until it sees the deceleration again. It does this very quickly before the tire can significantly change speed. This results in tires slowing down at the same rate as the car, with the brakes keeping the tires very near the point of braking at which the tires will start to lock up. This gives maximum braking power to the system. When ABS system is in operation, you will feel a pulsing in the brake pedal. This comes from the rapid opening and closing of the valve. Some ABS systems can cycle up to 15 times per second. So I hope the concept of ABS is clear and what is called cadence braking system or cadence braking technique, which is the foundation of ABS system. So before moving on to the next active safety system, I want you to know two more braking techniques. Okay, the first one is threshold braking. It is the maximum amount of brake pressure the tire can withstand before the vehicle tire locks up. ABS system knows how to sense this limit. Next is cover braking. Cover braking is highly useful in city driving. Cover braking provides smooth transition from acceleration to braking and is effective for slowing in the reduced stopping distance. I hope these techniques are clear. So let's move on to the next active safety system, which is the traction control system. The next active safety system we are going to discuss is traction control system, also known as TCS. TCS prevents spinning of the driven wheel during an acceleration, either by braking the spinning wheel or by reducing the driver torque. ABS and TCS ensures driving stability and maneuverability. Traction control helps limit the tire slip in acceleration on slippery surface. On a slippery surface, driver has to feather the gas pedal to prevent the wheels from spinning widely. TCS eliminates the wheel slip and helps the driver to accelerate under control. In modern vehicle, traction control system utilizes the same wheel speed sensor employed by the ABS. These sensors measure difference in rotational speed to determine if the wheels that are receiving power have lost traction or not. I hope the concept of TCS is clear. Before moving on to next topic, it's important for us to understand how TCS and ABS is different. The major difference between anti-lock braking system and a traction control system is that while ABS stops the wheel from spinning while braking, TCS stops the wheel from spinning while vehicle is accelerating. A TCS for this reason is also called an anti-slip regulation. So let's move on to the last active safety system, that we are going to discuss in our webinar. The last active safety system is Electronics Stability Program. Imagine you're driving at a high speed and you suddenly notice a puppy on your path. Then won't you turn your car so that the poor puppy is not hurt? I don't want to hear from anyone say that I'm not a dog person, I'm a cat person, so I don't mind. Okay, it's human to turn and ensure the puppy is safe. In doing so, your car might lose control and skid, and due to this, you can experience an accident. To avoid such a situation, electronic stability program is introduced. Electronic stability program increases driving stability actively in all driving situations. This leads to reduced risk of skidding, maneuverability maintained even in extreme situation, significant decrease of severe and fatal accidents. Though we have seen the ABS, TCS, and electronic stability program as a separate topic in this webinar, I feel it is important to mention that all three topics work together to ensure accidents are avoided. Okay, so with that, we'll have completed the active safety system and we are moving on to the next slide. The next few slides are easy to understand and hence we will quickly go through them so that we have more time to discuss the career opportunity and the skills required to get a job in this domain. Next topic of our discussion is infotainment and navigation system. Infotainment system is the in-vehicle system which provides the user to different functionalities such as multimedia, navigation, connectivity, car control, and information. Under multimedia, the following features are included: audio, audio setting, radio, station info, station control, traffic control, media player, TV or video control, external node source, connection via LVDS, and so on. So this is a list of multimedia features which you can see in your car. In this slide, we are going to discuss about navigation features. So navigation features included in the car are onboard navigation system, GPS, which stands for Global Positioning System, speedometer, gyroscope for direction change, correction using GPS signal, map matching, dynamic route guidance using TMC data, off-board navigation, route guidance by combining telecommunication and navigation, and so on. So let's move on to the next topic, which is connectivity. Connectivity covers the following features in car: call control, connect, conferencing, phone dialing, Bluetooth, USB connectivity for iPad, and multimedia playback. So these are the features of connectivity in a car. The next topic for today is instrument clusters. So let's say you are inside a car and you sit in the driver's seat. You will notice your dashboard with many dials, okay, the speed dials and many other instruments. That entire setup is called an instrument cluster. Okay, so instrument cluster is the meter that you see in the driver's seat. It includes speedometer, tachometer, odometer, trip meter, brightness adjustment, clock, and turn indicators. Now let's look at some of these instruments and what is the purpose of these instruments. Starting with speedometer. Speedometer is an instrument used to measure the instantaneous speed of your vehicle. So when you're driving your car, at any given point of time, what is the speed of your car? That will be measured and displayed by speedometer. In India, speedometer will display in kilometer per hour unit. In some foreign countries, it will be miles per hour. The next topic is odometer. It is an instrument used to measure the total distance covered by your car. Let's say today you purchase your car. So from the moment you take your car from the showroom till so many years that you have been driving, the entire distance covered by your car will be measured and displayed by your tachometer. Now the next meter we are going to see is an interesting one. It is called a trip meter. Let's say you don't want to see what is total distance you have covered and you want to measure only the distance for a particular trip. Say you decide to travel from Chennai to Mumbai and you want to measure the distance in your car, then you can use this trip meter, which is nothing but a plastic switch. You can press the switch a couple of times and you will see the meter in odometer. Okay, the values in odometer will be set to 0. That is, it will be reset. And when you start your trip, it will start calculating the distance from 0. So trip meter is a very interesting meter which lets you calculate the total distance traveled in a particular trip. I hope the difference between odometer and trip meter is clear. So the next important meter we are going to discuss is tachometer. So if you have driving license and if you have experience of driving a car, I'm sure you would have noticed the moment you start your car, even before your car starts to move, okay, there will be a meter which will start showing values greater than zero. That is, you'll have one dial that will keep moving up and down. If the value in that dial will be more than zero. That dial is nothing but tachometer, which measures the engine RPM. The minute you start your car, the engine RPM will be measured and displayed by the tachometer. I hope these meters are clear. So with that, we'll move to the next topic. So the next topic is body control module. This module includes HVAC system, power window, central locking system, immobilizer, wiper control system, and sunroof motors. This module is responsible for air conditioning inside the car, and it also ensures safety. Immobilizer is a term that is used for electronic keys. If you remember, in those days, we used to have Maruti 800, which will have a simple key. But today you have central locking system, and the keys will come with a huge device attached to it, which will have at least three keys. One is to lock your system, and the other is to create buzzer, and there's another key for a different purpose. So this is called an immobilizer, which is nothing but an electronic key which will ensure safety of your car. So we'll move on to the next topic, which is the in-vehicle communication system. The cars in-vehicle communication system include multimedia, consumer interface, infotainment system, body electronics, sub-bus, powertrain and vehicle dynamics, and safety buses. So the next two topics, so with this we have come to the end of all the technical topics that we had to cover. And the next two topics are the most important topics for today's webinar. In the next three slides, we will be discussing the career path, job opportunities, and skills required to establish a successful career in electronics domain or in automotive electronics domain. In 2013, the Government of India launched National Electric Mobility Plan 2020. I'm sure you guys would have heard about this plan. It's a highly ambitious plan launched by Government of India in 2013. Let's look at some key points of this plan. It encourages reliable, affordable, and efficient electric vehicle that meet consumer performance and price expectation. This also aims to increase government-industry collaboration for promotion and development of indigenous manufacturing capabilities, required infrastructure, consumer awareness and technology, thereby helping India to emerge as a leader in the electric vehicle market in the world by 2020. The ultimate objective of this mission is to achieve global electric vehicle manufacturing leadership, and contributing towards national fuel security. In short, this plan aims to achieve national fuel safety by promoting hybrid and electric vehicle in our country. Government also launched a scheme called FAME, F-A-M-E, which stands for Faster Adoption and Manufacturing of Hybrid and Electric Vehicle Scheme. Under this scheme, government has approved pilot projects, charging infrastructure projects, technological advancement projects aggregating to a total of $24 million. Graphical research reports that autonomous vehicle in Asia Pacific region will increase to 24 million units by 2024. Graphical Research is a business research firm that provides industry insights, market forecast, and strategic input through granular research and advisory service. And I happen to read a report from such a wonderful institution which says by 2024, we are going to have 24 million autonomous vehicles in Asia Pacific. Now, similar to Graphical Research, we have another company called Bloomberg NEF, which is a leading provider of primary research on advanced transport. Bloomberg NEF report claims that shared mobility services will adopt the electric vehicle faster than private owners. And by 2040, around 80% of the global ride-sharing fleet will be attributed to electric vehicles. In India, ride-sharing fleet market is dominated by Ola and Uber. Now we have seen all these facts. Now the question is, what does all these facts and developments mean to an electronics engineering student. This means there will be a lot of companies investing in electric vehicle, autonomous vehicle, and because of all this, there will be good job opportunities in this domain. So based on all this development in the industry and government taking the required actions, I am confident that there will be immense job opportunities in automotive electronics domain. I hope the facts that I have presented here convinced each and every participant of the webinar that it is a good idea to consider a career in the field of automotive electronics engineering. So with that said, we have seen some technical concepts in the field of automotive electronics to get a feel of what is included in automotive electronics. And then we have also seen what are the career opportunities that we have based on the developments happening across the globe. Now the next question is, how can we capitalize on these opportunities? Now that we have seen there is enough opportunities in this domain, let us also see how to capitalize these opportunities. For that, we need to understand the skill sets required to enter this market domain. The present trend in automotive industry is electric, autonomous, and connected technologies. Hence, one should possess in-depth understanding of electronics behind these technologies. Let us see what skills you need for the same. One must be an expert in embedded system. To truly become an expert in embedded system, you must start with any 8-bit microcontroller and then gradually progress to 32-bit microcontroller. As you all might know, embedded system is a combination of hardware and software, so a strong C programming skills is a must to ensure a job in automotive domain. Exposure to sensors and transducers and how to integrate these with microcontrollers are sought after skills in industry. I've already mentioned the list of sensors that is available in the car, but don't be kind of anxious or scared by looking at the sheer number of sensors that is available in the car and the fact that you have to integrate all this. You have to just find out how to integrate three types of output from sensors. You take any sensor, it will have either analog output, digital output, or PWM output. And if you have figured out how to integrate these different outputs with a microcontroller, then you are already a sought after candidate in automotive electronics domain. So as mentioned before, connected car is the talk of the town. Connected car is an application of Internet of Things. Having practical exposure to Raspberry Pi and working on a couple of IoT projects will increase your chances of success in placement. One must strive to gain practical experience in embedded communication protocols like I2C, SPI, CAN, LIN, and UART. Technical concepts like control systems, electrical machine, RTOS, and signal conditioning circuits must be mastered. So in short, you must possess strong C programming skills, must have exposure to practical concepts of embedded system, have experience working in Raspberry Pi, understand the electrical machines well, and be able to design a signal conditioning circuit based on the requirement. So what is a signal conditioning circuit? You have embedded system, which is nothing but a microcontroller. And as you all might know, microcontroller can handle only low voltage. Some microcontrollers can handle up to 5 volts, and some microcontrollers can handle up to only 3.3 volts. So when you have to integrate microcontroller to a sensor and ensure the car moves or car performs some action, you have to provide more voltage. But your microcontroller can provide only less voltage as an output. So you need a signal conditioning circuit that can enhance this output and achieve the objective. And that is why signal conditioning design experience and knowledge is very important when considering automotive electronics domain. I would like to talk about one more point, that is the career path. So if you are a fresher or just graduating from industry or from your university, you will be joining as a graduate trainee for some companies or as a junior embedded software engineer. And from there, your career will start. Typically, you'll be judged based on your knowledge in electronics, embedded system, sensors and transducers, and definitely programming, and the practical projects that you have designed or worked in your undergraduate engineering or postgraduate engineering. And with that, you'll be judged and you'll be given a job. So the next point I want to discuss is the target companies. So we have covered automotive electronics concept. Now we should also know which companies will be interested to recruit an engineer with such a knowledge and skill sets. So I'll just mention 4 or 5 companies, starting from Robert Bosch. Robert Bosch is tier 1 supplier of automotive electronics parts. It is one of the leading companies in the world, and it's a German-based MNC. And this company will be interested in candidates that have good exposure to automotive electronics. The other companies include Mahindra and Mahindra, Ashok Leyland, Continental, and Tata Motors. Now these are your target companies. So with this, I have come to the end of my session.